Is summer and the Southern Hemi making a return? I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, October 13th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time. No hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. If you have a comment or a question, write it up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Our usual cast of donators, Our Predicament, Evolution Moto, Tim Caston, and SV Lone Star. Thank you all so much. And SV Lone Star, generous contribution. Also, Mark Herlock, Nathaniel Glickman, KMJ Berto, all contributed and at a significant level as well. Thank you all very much. And with that, let's get to work. We'll start by looking at significant wave heights for the entire planet. Starting in North Pacific, remnants of a gale. They are still producing 20-foot seas aimed at the U.S. West Coast and down into Hawaii. Swell is in the water and on the way. Down south, not a whole lot going on. A little bit of a gale here south of Tasmania, but not expected to significantly push into the South Pacific Ocean. But in the Indian Ocean, a broad gale, much stronger earlier, still is producing, 27-foot seas right there. The highest seas over this entire domain in the frame. That is the highest seas anywhere on the planet at the moment, targeting Perth, Bali, the Mentawai Islands, and a little bit into southern Australia. Another gale also pushing under South Africa, again with like 26-foot seas, but not as significant as this other one. In the Atlantic, things kind of quiet for the moment, maybe a good thing after a very active week in the Gulf of Mexico into the, I guess that'd be the Western Atlantic off the U.S. coast. And there's also been quite a bit of activity pushing into Europe as well. So things taking a breather for the moment. But first off, let's take a look at current conditions. We're going to start a little bit further north in California. We're going to call it the Pacific Northwest in general. No place in specific. Buoy number 162, Clatsop Spit, off of Oregon. We're looking at all the energy that's hitting that buoy all the way up from super long period, 33.3 second period energy, 0.0 feet worth there, a little pocket of energy in the 20-second period range, and then a little bit more down in the wind swell category range, 9 feet, something like that. Put it all together, swell, primary swell, 3.4 feet at 9.5 seconds from 241 degrees. So basically wind swell at waist high, something like that. And the longer period swell, this 12-second period swell, maybe there is a little bit of them looking here. I don't see much. So it's more like leftover energy. There is some southern hemi swell in the water there out here if you can find some exposed south-facing break. But all in all, pretty quiet in the Pacific Northwest for the moment. Then, of course, we go to Northern California. We're going to start at Point Reyes, California, really sort of almost more Central California, 029, Point Reyes, California. We're looking at all of the energy hitting that buoy. Now, we do see this pulse of wind swell and leftover swell. There was a swell from just a generic know-nothing gale that was off of Northern California, Oregon, something like that a couple days before. Seas were barely 20 foot. We'll go look at that in a minute. Swell way overperformed, waves several feet overhead and with decent conditions. A complete sleeper swell. The models didn't catch it. Nothing caught it. But if you were there, you caught it. And then also this long period, 18, 19, 17 second period swell coming from the southern hemi. We'll see more of that here when we get down to Southern California, but definitely swell in the water. Primary swell says 4.6 feet at 10.3 seconds from 270 degrees from the west. That's surf at about 4.5 feet, and that's about what it was, but it was bigger this morning and way bigger the day before. And then the secondary swell, that southern hemi swell, 1.5 feet at 17.5 seconds from 192 degrees. That would be surf at waist high, but it's probably bigger than that. The problem is the northwest swell is pretty much just bearing the southern hemi swell anywhere north of Point Conception. So then we head south, Point Loma South Buoy, that's off of San Diego, buoy number 191. Now you see more this mix of, here's the southern Hemi swell. It says 1.1 feet at any one period band, but you've got to actually add multiple period bands together to get the entire picture of the swell. You also see bits and fragments of that swell that hit Northern California filtering through the Channel Islands, trying to reach into Southern California in the, say, 13-12 second period range, and then some wind swell mixed in. Put it all together, primary swell 3.1 feet at 12.3 seconds from 261 degrees. That is that westerly swell. It gets a bit warped by the Channel Islands as it comes in, flattens it out, makes it more west than it really is. Surf heights 3.8 feet. Okay, secondary swell, 2.2 feet at 16 seconds from 212 degrees. That would make surf supposedly 3.5 feet, but it was a foot or two overhead at the top south-facing breaks in Southern California. You know where and you know how to get to it. But all in all, it really looks like summer has arrived again, finally, maybe, for the Southern California. Then we go over to Hawaii, South Shore. We're looking at the buoy number 239 on Lanai because it's shadowed from or filtered out from any northwest swell or wind swell, whatever. See the clear bump here. Now, this swell doesn't have the 20 seconds. It's already kind of on its way down, but you see a good clear bump here in the 13 to 14 second range, 2.7 feet at 13.5 seconds from 173 degrees. This is actually almost sideband energy, going almost backwards up into Hawaii. Surf heights, 3.7 feet calculated. Yeah, it was chest, shoulder high, maybe even some bigger sets at some places. And that was the main swell, or is the main swell happening there. And then finally, not to be left out, we'll go to the north shore of Oahu, the Waimea Bay buoy number 106. Not a whole lot going on, a little bit of wind swell, and you see some bits of southern Hemi energy trying to show up, but really, not really rideable on the north shore. Primary swell 2.6 feet at 9 seconds from 344 degrees. That surf height 2.4 feet. It was, maybe waist high, something like that this morning when I looked. So there are waves, and then there's some background energy in here, but it really doesn't count. All right, so let's go do our Hindcast. We're going to look all around the planet, starting in the South Pacific Ocean on Thursday, the 3rd of October. A gale developed south of New Zealand with 31-foot seas, building while tracking east. Not huge, got up to, maybe 32 feet, 31.9 feet there, and then traversed. Sort of didn't build a whole lot, but what it did do is start lifting hard to the north on Friday, the 4th of October, seas at 28 feet, continuing in the 28-foot range and into Saturday, then fading from 26 feet, and then got another little second wind as it got into Sunday. So this was last week while we were doing our forecast, the 6th of October with 27-foot seas and then fading from there. That is the swell that is fading in Hawaii now. Now, again, let's go put this back in perspective. Hawaii, Oahu's like at 158 west, so roughly right here. And you see the storm was lifting barely due south of the Hawaiian Islands, but really most of the energy pushing off to the northeast rather than due north. So it was sideband energy pushing into Hawaii. The bulk of this swell is just poised to start hitting Southern California and up into Northern California on Monday. And that was all that happened down the Southern Hemi. Nothing since then. Looking in the North Pacific, here we are on Thursday, the 10th of October, this little gale, and here we'll show you about what it did. That was about it. Maybe there's one more frame. Either way, that's 19-foot seas aimed at California. Now, it's really close to the coast and a rather westerly direction, and that produced the swell that hit on Saturday. In fact, you could probably see it while that swell was approaching the coast. A new gale started developing in the northwestern Gulf of Alaska with 26-foot seas, building to 28 feet on Saturday. There you go, and 29 feet. And then continuing on through the day, Sunday, while slowly fading. Whoops. So you can see that swell front approaching. The swell that is currently hitting California is to be fading out, providing theoretically a relatively clean slate for the next swell coming in behind it. Then we go to the North Atlantic. We're really focusing down here on Milton, but there was this other tropical system that went extratropical, targeting Europe. We'll get into that so you can sort of see the blob heading towards Portugal with 43-foot seas. Milton developing here, pushing right into the Tampa area on, we'll say, Wednesday evening, early Thursday. Peak winds forecast, I think they were 120 miles an hour. The highest wind gust recorded in the Tampa Bay area and where main landfall was supposed to be was about 102 miles an hour. So maybe a little bit overhyped. That said, what it did do is produce a lot of rain. Tampa and that area really got soaked hard, and north of a line, basically along the I-4 corridor, lots of water up in there. It backfilled all into the inland rivers, is bleeding out into the ocean now. But there's a lot of people that took a major hit, especially on the barrier islands here on the west coast off of Tampa. That on top of what happened in North Carolina and the Asheville area and around there. You can go look on YouTube and see some of the devastation those poor folks are going through as well, from heavy rains, swollen rivers, washed out roads, no power, flooded homes, if not homes uprooted and washed down rivers. So just a horrible situation. I strongly urge, if you want to donate, find a reputable place to donate to and help folks out both in North Carolina and Florida. Not a pretty situation. The atmosphere definitely has woken up and is extracting its revenge. All right, moving on through. So that got us to Thursday. Milton continued off the Florida East Coast, produced some swell, but some windy conditions into Friday. That's fading. Here we are almost on Saturday now, the 12th of October. And let's see, that gets us to current right about now. Not a whole lot going on. Maybe that's a good thing. Everybody needs a break. Onward to the South Atlantic, we're just going to blast through this. Yes, there was a gale here off of South Africa on Friday a couple days ago. Swell is inbound if it has not already hit for select spots in South Africa. But after that, there we go. After that, things are pretty quiet. But the Indian Ocean does not want to be left out of the action. A solid gale, if not a storm, developed on Thursday. This is just a couple of days ago, the 10th of October, with seas. Let's see if I can see this. 39 feet to 40 feet. That was about it, but over a really solid area. Again, at 40 feet, there you go, 41 feet. This is into Friday night, all pushing off to the east and northeast swell. You can see the swell front right here will get us up to current time. There you are. See the swell front poised to hit into Western Australia and eventually going to make its way up into Bali and the Mentawai Islands. Good late season swell is on the way. All right, so let's go look for the next week out. What's going on? We're going to do our zoomed in forecast on the North Pacific to start with. We're looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a dip in the jet. We see it right there. Here's the jet. Well, let's get ourselves oriented. Kuril Islands, Kamchatka up here, Japan down here, the Aleutian Islands here, Alaska, Canada, U.S. West Coast. There is a dip in the jet. It's known as a trough. What a trough does is help create a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. Of course, low pressure, if it's strong enough, gets traction on the ocean surface, starts generating winds. Those winds impart energy to the ocean, creating seas. Seas, as they radiate away from the fetch area, the shorter period elements fade out, eventually exposing swell. And swell, when it hits your beach, generates surf or creates surf. So it all starts with a trough. We do have a trough here in the northern Gulf of Alaska. You saw the Hindcast data. This is remnants from a gale that was up in this area. That is to be fading as we get into Monday. The jet, though, reasonably, it's split over here over Russia, but then all sort of comes together and is consolidated for the most part across the North Pacific. We're looking for a trough. We don't really see it. If anything, we see a ridge here. Now, a little bit of a trough forecast Wednesday. Looks like it's going to maybe make a backdoor trough pushing down the U.S. West Coast, but likely inland, not doing anything for swell development. Then we see something here. Let's see how this starts And there you go, the beginnings of another trough, but this isn't till like Friday, way out here on the date line. Good wind energy starting to feed into it, but it falls hard south, which is good, but it's kind of pinched. It's not like a broad trough, it's a pinched trough. We'll see how well that supports gale formation. And you end up with this high amplitude jet pattern, big ridge pushing up into the Bering Sea doing nothing, a tight trough over the date line, and then ridging going up into Alaska. Now notice this cutoff low. In fact, let's put this back into motion. We saw that starting to develop on Thursday, the 17th of October, as it falls south, interior, inland, down into Southern California, then gets cut off there and just lingers until about almost late Sunday when it finally is out of the picture. There is energy in the jet stream, but it's kind of a little bit wonky on all over the place. So it looks like the North Pacific, for the most part, might be taking a little bit of a break. Let's go down to the surface. Here we are, surface level pressure, surface level winds. The gale in the Gulf of Alaska still producing 30-knot northwest winds. That's capable of generating like 11 to 12 second period wind swell, but that fades out pretty much on Monday. After that, we know there is one trough forecast. Now here's this little low that's forecast winding up Thursday in the northwestern Gulf of Alaska, but the winds, well, there are 30-knot winds, but they're all aimed north up at Alaska. That's not going to do anything. And notice, in fact, let's go back here. Notice 30-knot northwest winds along the entire north and central California coast, maybe even creeping into Southern California. High pressure, that looks almost like a return of spring or like summer, if you will, hence some of the title of this video. Anyway, probably a blown out mess for the most part after having decent swell for a while here. We'll just roll this out and see. Really everything off to the north, cut off low on Sunday, north of Hawaii, doing nothing, and that is about it. So what are the effects of those winds on the ocean surface? Well, we'll take a look here. We know we have 20-foot seas up in the northern Gulf of Alaska, but that's quickly going to fade out. You see the swell front hitting late Monday night into Tuesday into California and also into Hawaii, and probably more on Monday, and then fading out for, slowly fading for a couple of days. We're looking for even, I'll take 20-foot seas. There we go, 25-foot seas, but we know they're all aimed off to the north. You can look at the little arrows here, the directional spectra, all heading up into Alaska. Nothing there. And then after that, well, it doesn't look like anything aimed at either Hawaii or the U.S. West Coast for the moment. So a little bit of a break for the North Pacific. So then we go look at the South Pacific, Australia, New Zealand, New Guinea, Chile, and Peru, South America right there. Put this into motion. A little gale is forecast developing on Monday in the South Central Pacific with 32-foot seas, building to 35-foot, holding at 34 feet and then fading, all aimed well off to the north. This would generate swell for sure for South America, Mexico, on up into California in the swell window for both North and South California. And seeing how it's all supposed to be done before we even hit the 72-hour mark, odds of it actually forming are pretty good. So maybe another southern hemi swell on the way and aimed pretty well to the north. And then behind that, let's see if we can find this right here, starting Friday. Yet another gale is forecast developing southeast of New Zealand with 29-foot seas building to 31 feet, 32 feet, 33 feet, lifting again off to the northeast. I mean, it's the middle of October, and it's like what we should have had in late July and August when when the entire Pacific basically just went to sleep. So it seems like we're making up for lost time. I'll take it. That's a good thing in my book. A quick look at the North Atlantic. We'll just put this into motion. A gale is forecast in the deep North Atlantic, really targeting Europe for the most part and not even significantly. 30-foot seas for a minute there, Monday into Tuesday, the 16th, or the 15th, I'm sorry, of October. And then lesser seas pushing into Portugal and that area. Certainly some swell to result. And then maybe another little bit of 27-foot seas on Friday, targeting Ireland. So some surf from that. We'll push this on out and see. And then after that, things quiet down a little bit. There are also, if you notice this, I was looking up north, but we'll go back right here. You see theoretically some sort of a tropical something forming off of, we'll say, well east of the Virgin Islands on Thursday, the 17th of October, and then tracking pretty much due west and fading as it pushes into the Dominican Republic. The odds of this happening are very low. The GFS model, well, it actually has done pretty well. I mean, Milton, it picked that one up 2 weeks ahead of time. It did the same thing with Helene. So we'll keep our eyes on that. Hopefully, for hurricane-weary people in Florida and the Gulf Coast, it won't make it anywhere near there. South Atlantic, we'll run through this real quick. Really not, I did a quick review. I don't remember seeing anything of any major importance going on for the next week. No big surprise. It's that time of the season. Then we go to the Indian Ocean. Here is the remnants of that storm that had like 41-foot seas. You see the swell front approaching Western Australia, hitting it on Monday, bound up into the Mentawai Islands in Bali area as we get later into Tuesday, the 15th of October. This is all GMT time. Adjust accordingly for your local break. And then after that, a quieter pattern. Just roll this through here. And that is it. So one last maybe good solid swell for the Indian Ocean, probably before the season shuts down. Local wind forecast for California right here, North California, Central California, Southern California, Hawaii right here. Low pressure in the Gulf of Alaska, weak high pressure in between Hawaii and the U.S. West Coast. A rather weak wind pattern. As we get into Monday, the high pressure tries to get a little traction, but there's a lot of low pressure here in the Gulf. Doesn't really do a whole lot. Northwest winds 10, 15 knots. Trades 15 knots for the Hawaiian Islands. Tuesday, pretty much the same thing for California. Stronger trades, notice high pressure getting more organized. The trades build 15, almost 20 knots for the Hawaiian Islands as we get into Wednesday. Then Thursday, low pressure clears out of the Gulf. High pressure returns. It's like a summertime pattern all over. Northwest winds 20, 25 knots, raking down the Pacific Northwest and California coast. Pretty much a blowout. Trades 15 knots. Thursday, it builds late Thursday. You see it building 20 to 25 knots for California into 30 knots for all of North and Central California. Yes, wind swell, but it'll also take that nice warm surface water and just upwell the heck out of it. Hopefully it doesn't last too long. Trades light for the Hawaiian Islands. So we get into Saturday. Fortunately, that gradient and the pressure and the winds start fading. Still 20, 25 knots off of Cape Mendocino, but south of Point Arena, 10 knots, something like that. So not too bad. And all gone by late Saturday into Sunday, a week from now. So, and trades continue for the Hawaiian Islands. So a wind swell mess later in the work week for California. A quick look at potential for weather for the California coast. Now, not much, but we're just looking for precipitation. We know there is some little gradient thing going on, and typically if there's a gradient, there's low pressure involved. We see weather, rain, I guess you would call it, Wednesday night over the Sierra, but the coast itself is clear, falling south with maybe even some snow or sleet in higher elevations late Wednesday, and then a more pronounced, not a dump of any kind, but at least a smattering of snow forecast for the Sierra from Tahoe down into, it looks like about the Mammoth Range on Thursday night, then quickly fading out and gone from there. And after that, a dry weather pattern with high pressure in control for a moment, but then it looks like another front a week out. The snow forecast dashboard, we're just going to look at Palisades, Tahoe, formerly Squaw Valley. This is an inch or an inch and a half of snow on the 17th, and then just holding after that. And we can look here at the upper level temperature profile. This is the top of Palisades, Tahoe at about 9,000 feet. The base down at about it's actually 6,200 feet. Blue is freezing, good cold freezing temperatures below 28 degrees. So you see freezing temperatures the whole way down to the base, if not lower than that, down to almost 4,000 feet for just a moment on the night of the 17th. We can see it better here on the hiker's temperature elevation forecast. This is at the intersection of Pacific Crest Trail and Tioga Pass Road there in Yosemite. Probably a pretty good hint at what, things would happen also down at Mammoth, that sort of thing. Temperatures, so this is the intersection level, 8,700 feet there, the PCT in Tioga Pass Road. And temperatures, roughly 50 degrees, into about Wednesday. But then you see them starting to fall. This is the freeze line here. Freezing temperatures down at about, 5,000 feet, dropping to 4,000 feet on Friday night. Now that's still 5-6 days away, so we'll see. But definitely associated with that low pushing down the spine of the Sierra, bringing some snow with it. So a pocket of winter trying to show up for a moment, but by the time you get into Sunday, temperatures already on the rise and back into the 50-degree range as we get into Tuesday morning on the 22nd of October. So a hint of winter coming, typical of fall. Surf spot forecast, we're going to do the Pacific Northwest just in general. 13-foot waves theoretically on Monday from that new swell coming from the Gulf of Alaska, then slowly fading from there. Primary swell size, 8.6 feet at 15.5 seconds, slowly working its way down. Then some sort of wind swell, smaller, all after that. For next weekend, 4.7 feet at 10 to 11 seconds, so some wind swell in the mix. For California, North California, Ocean Beach, San Francisco, surf heights, roughly 8.5 feet, with a good amount of northwest wind. This would be on Tuesday morning, then slowly fading. You see, so it won't be down at 2.5 feet, but notice the winds, 30 knots out of the northwest. So just pure unadulterated wind chop. It doesn't register as swell on this graph. So you get the idea here. But the main swell, 5.5 feet, almost 6 feet at 14 to 15 seconds on Tuesday, then fading from there. Wind swell, when it finally registers as swell, 6 feet at 9 seconds, but I would expect 8 or 9 foot seas during the wind swell period. Southern California, the southern Hemi swell, it shows as 3 feet, and that's supposed to continue into Tuesday and Wednesday, slowly fading down. The reality is, if you have good bathymetry, it creates or enhances the swell size, and it's not unusual to get wave heights twice the size of what is forecasted from open ocean swell, and that's basically what you're seeing here. Primary swell, 2.3 at 15 seconds as you get into Monday. It'll probably be higher than that, in fact. And then slowly fading down with the period down at 13 seconds, even on early Thursday, and slowly fading from there. But the wind swell is going to come in and probably just junk it all up, even into protected breaks in Southern California. North shore of Oahu, also to get the Gulf swell, surf heights 10 feet. That might be a little overstated, maybe 9 feet, something like that. And 9-foot Hawaiian, yeah, okay, we'll say, double overhead, something like that. Then slowly fading, because after that, North Pacific kind of goes to sleep. Primary swell size is 7.5 feet at 13 seconds. Earlier Monday, 7 feet at 14 seconds, something like that. And then slowly fading down, 2.7 feet at 10 seconds late on Thursday into early Friday. Then maybe another little pulse of some background energy in the 2.5 feet at 10 to 11 seconds. So that's just all wind swell. I couldn't find a good graph for for the south shore of Oahu, but the short of it, just because the wind swell kept coming in, or the northwest swell kept coming in and polluting it. But the southern hemi swell that's hitting there is supposed to be slowly trickling down over the next several days. We go over to Florida, Cocoa Beach, Florida. Surf heights pretty small, getting really small, but then popping up as we get into next weekend, maybe 5.5 foot surf. you see northeast winds, a big fetch of northeast winds coming at 20 knots, pushing into the coast. Swell sizes, 7 feet at 8 seconds sort of thing. So a typical kind of fall season for the southeast coast. Not a northeaster per se, but a northeast wind pattern typical of fall, producing surf. Then we jump over to the Indian Ocean real quick. With that big swell forecast coming into the Western Australia, surf height 16 feet as we get into Tuesday, and then fading from there. Swell size 9 feet at 17 seconds. That is real swell indeed, and then fading from there, and then some sort of follow-on wind swell 9 feet, falling to 5 feet at 10 to 11 seconds sort of thing. And then Bali also sharing in on the action. Surf heights 17 feet, probably not 17 feet, maybe at some select secret break somewhere, but still very solid surf likely for Mentawai Islands in Indonesia, that area. Swell size 10 feet at 17 seconds. That is a real swell. And then that would be on Wednesday, and then fading from there. Actually, let's see. Oh, and these dates are accommodated for the time and change. So that's the local time. So this is in fact Wednesday afternoon local time. All right, let's go take a look long term. What's going on with the two major oscillations that affect weather on the 2-week to a month to multiple month-long scale? The MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We'll start by examining the MJO, the Madden-Julian Oscillation. There are two phases to it, the active phase and the inactive phase. They rotate around the planet from west to east. The active phase on one side of the planet, inactive phase on the other. They rotate west to east around the planet on the equator. Active phase on one side, inactive phase on the other side of the planet. The active phase is our friend. It is effectively a low pressure system. When it moves over your part of the ocean, what it does is it drops pressure. That in turn reduces trade winds. Weaker trade winds allow warm, moist air at the ocean surface to lift up into the atmosphere. That gets the jet attacks it, or it gets integrated into the jet stream. It makes the jet stream stronger. A stronger jet stream starts digging out troughs, helps support the formation of gales and low pressure systems. The inactive phase of the jet stream does the exact opposite. It's like a high pressure system. It shuts down the flow of moisture up in the atmosphere, steals energy from the jet. The jet splits, can't figure itself out, and then is not as effective at supporting gale formation. All right? That manifests itself, at least on this chart. This is a chart of zonal wind anomalies. Where are the winds stronger out of the east, that is stronger than normal trades, and where are the winds stronger out of the west, that be weaker than normal trades? The oranges and yellows are the weaker than normal trades. You notice there's sort of like a pattern of westerly anomalies going across the chart this way, and then another pattern of easterly anomalies going across this chart, and then another pattern of western anomalies going across there. So this would be the active phase. This would be the inactive phase. This would be the active phase. Now, this is the whole planet on one chart, right? We're interested in the Pacific Ocean. The date line's right up in the middle here. That's the center of the Pacific. Far West Pacific starts about 125 east. So here, so you can see the blues are easterly anomalies, the inactive phase. So you can see we had an active phase and westerly anomalies supportive of gale development in late September, and then pretty much out of the Pacific by the early part of October. For all of October, we've been in the inactive phase. The worst of it looks like it's going to happen in the next couple of days for the next week or so, and then it's gone. Then another active phase looks like it's going to set up as we get deeper into October. Also, remember, we think we have some sort of a La Nina base state in control. That sort of amplifies the inactive phases of the MJO and sort of suppresses the active phase. So notice, like, you have an active phase crossing here. Even at that, there were easterly anomalies right smack in the middle of it over the date line. That's pretty typical of La Nina. So for right now, inactive phase in control, but it looks like the active phase is coming shortly. Let's dig in a little deeper. Here's another way to visualize that. This is outgoing long wave radiation. Again, we talked about that warm, moist air jumping or being pushed up into the atmosphere, it eventually will hit cold air aloft and form clouds. This chart, outgoing long radiation, is if you have more clouds in the atmosphere, you can't get more sunlight bouncing off the ocean's surface and returning to space. So you get what they call negative anomalies. That's what this shows. So the blue is effectively cloudier skies, the red, dry air, high pressure, the inactive phase. So right now, South America, Central America, equator right there, the date line 180 west, Australia and New Guinea there. So West Pacific is really where the active phase does its thing relative to the jet stream, in that it pushes warm moist air up into the jet stream. The jet stream integrates that energy and then makes troughs downstream from where that integration occurs. So right now, a neutral MJO pattern forecast, but with a weak active pattern forecast 5 days from now, building to moderate 10 days from now and holding 15 days from now, so 2 weeks from now. So that would put us about the end of October. This is the statistic model. Dynamic model, lo and behold, suggests pretty much the same thing. If anything, the active phase getting a little bit stronger as we get towards the end of October. Nice. Here is a more detailed version of those same two models. The statistic model here, the dynamic model here. How do you read this? Well, the MJO moves from west to east, from the Indian Ocean, over the maritime continent, to the West Pacific, over the East Pacific, under the United States, to Africa, back to the Indian Ocean. The heavy dot, which is right there, is where the active phase is, so weakly over the maritime continent, like Bali. This is the forecast track. 1, 2, there's actually 3 of them. All of them show it moving to the West Pacific 2 weeks out from now, split between very weak and just weak, per the statistic model. The dynamic model here, though, has it building, just moving into the West Pacific 2 weeks from now and stronger at almost modest, not moderate, we'll say modest strength 2 weeks out from now. So a little bit of a disparity between the two models in exact positioning and strength, but all suggesting 2 weeks from now something moving into the West Pacific exactly where we want it. The upper level model goes out 40 days. 5 days each panel, 8 panels here. South America, Central America, New Guinea, 0 is the equator. Date line runs right down the middle here. This is just the Pacific. The green is wetter than normal air, active phase of the MJO. The orange and yellow, the inactive phase of the MJO. So this looks like the inactive phase setting up over the Atlantic now. And remember, this is upper level. It takes about 2 weeks beyond that for what actually happens down at the surface. So kind of a neutral pattern over the Pacific, but even 5 days, 5 days from now, active phase sets up over the West Pacific, makes its trek across the Pacific, out of the West Pacific by about the 7th of November, so in reality, that'd probably be about the 20th of November, something like that. Then here comes the inactive phase after that. So just looking at this, again, it suggests that late October, early November time frame for storm development in the Pacific. Then we have the CFS model. It goes out 1 month. Here's the 1 month forecast here. Here's past performance here. Date line right up the middle. Far West Pacific starts about 125 west, so right here. Now this chart shows you the MJO, this black contour here. That'd be active phase, the dotted contour, inactive phase. Active, this was in like August, early August. Late August, early September. Here was an active phase in September. Now here we go. Here comes our active phase moving across. Forecast now for the next week to almost 2 weeks till about late October. Then you see the active phase after that. Oh, and the blues are easterly anomalies. The reds and yellows, westerly anomalies. So here's our inactive phase with easterly anomalies. Probably not great for storm production. No surprise the North Pacific is shutting down for a little bit here, whereas before we had at least neutral anomalies. Then beyond that, active phase, westerly anomalies, making it to about 150 east, so maybe of a third to a half of the way across the Kelvin wave generation area. But you see these easterly anomalies persisting. And that typically suggests a La Nina pattern, a high pressure bias. In fact, the purple line here, it's called the low pressure bias. It's actually, because it's dotted, an anti-low pressure bias, so it'd be a high pressure bias. That's like the La Nina signal. So some hope here in later October, and then beyond that, it looks like another inactive phase following behind that. But we can dig yet deeper. Here is the CFS model going out 3 months. This is the forecast up here. This one does it different. Past performance is down here at the bottom. Dateline runs right up the middle. All important Kelvin wave generation area starts about 125 east. So from here, really, this is the main area we're interested. You see blues, that's easterly anomalies. Then you see westerly anomalies, the active phase, the MJO, working into late October and November. Now, earlier versions of this model, I got a bit excited about it because it just showed pretty much from somewhere starting right around here, it would be all yellows filling the entire Pacific. Now this model has probably gotten more with the reality of the situation, and it's, you know, the La Nina situation, if you will. We're going to dig into that in just a minute here, but this will give you the fundamentals. You see an active phase here, you see another active phase here in westerly anomalies, but still this persistence of easterly anomalies. The good news is it's mainly east of the date line, so that gives 50% of the, or pretty much the whole Western Pacific least being open to the potential for westerly anomalies and supporting injection of warm, moist air into the jet stream and feeding storm development. Let's overlay the MJO here. Let's just see if my guess is right. Dotted contour, inactive phase of the MJO. Again, the date line right up the middle here. So that into about, October 25th or something like that. Actually, the active phase starts October 21st, westerly anomalies, making it almost to the date line. So this looks like a reasonably good shot here for storm development. Then a weak inactive phase following that. No westerly anomalies, but not particularly strong easterly anomalies either. And then after that, a little bit more robust active phase of the MJO during the Christmas time frame. Now, again, I wouldn't believe a model that far into the future, but it sort of smells like the inactive phase, or the La Nina signal, not very strong at all. In fact, let's overlay the low pass filter. Here you go. Here's the low pressure bias this is basically Indonesia, Indian Ocean. No big surprise. This is classic La Nina, but only with, well, there's 2 contours, but just barely, and for a couple of weeks. So not too bad. The high pressure bias, here's where it was over the date line. It died in August, so we've been living at least not under the threat of that. It is supposed to return weekly October 21st and then hold after that. But notice only 1 contour, not very strong. If this is an incredibly weak La Nina signal. It is La Nina just because of the easterly and the prevalence of easterly anomalies and the weakness of the active phases, the MJO, but not particularly strong, bordering on almost neutral, but definitely, modest at best La Nina signal. All right, so now to the El Nino, La Nina part of the discussion. We're going to start by looking at data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino, but they also have right here, you can see these. The anchor lines on the buoys with the X's are sensors strung down those anchor lines, so you can see the movement of warm and cold water across the equatorial Pacific, 2 degrees north to 2 degrees south. When warm water is more or less all balled up in the west, that means trades are blowing stronger than normal from east to west, and that typically is suggestive of some flavor of La Nina. So we're looking the 30-degree isotherm. You can barely see it, like 1 pixel of it right here at about 160. That was bigger the past couple of weeks, suggesting trades are picking up a bit. The 29-degree isotherm at 180, I think was over about 175 2 weeks ago. The 28-degree isotherm this is Celsius degrees at about 167, 168 west. That's where it's been. So a little bit of rearrangement of the details, but the big picture generally the same. The 24-degree isotherm actually looks much better, strung the whole way across the Pacific, but notice there's no sensors here, so a lot of this is just like a big question mark. But it is not the actual water temperatures that matter. It is the anomalies, the difference from normal for this time of the year. We see a pocket of warmer than normal anomalies, not particularly warm, 1 degree above normal here in the west, theoretically 2 to 3 degrees in the east, but again, big blocks of area where the sensors are down. I think they're out there trying to upgrade some of that. And down at depth, only 1 degree below normal here. So this If this suggests a La Nina pattern, it is incredibly weak La Nina, but again, some of the data is suspect here. So we'll go look at another set of that data right here. See if we can get that broadened out for you. And this uses satellite data to try to get a finer detail of what's going on. This suggests warm temperatures in the west, cool temperatures in the east, the dividing line right about 160 west, so a point south of Hawaii. Now, the good news is here, warmer than normal anomalies are filling the entire West Pacific and pretty much blocking the movement of cold water from west to east, suggesting maybe this is the last pocket of cool water for this La Nina. We're not even in deep in the La Nina period. I mean, typically La Nina peaks around Thanksgiving, but it looks like it's being starved for cold water and cut off, not by a building El Nino or anything, but just by kind of ENSO neutral. I'll take that any day of the week. So still a cold water regime here, but not like strong and not showing any signs of building. This is the satellite data used to support that previous chart, sea level anomalies. Is the sphere of the ocean higher or lower than normal? That is, take out the wind waves, take out the waves, take out the tide, and is literally a perfect normal sphere of the ocean higher or lower than normal. Why does that matter? Well, if you have cold water at depth, cold water tends to contract. You'll end up with a divot on the ocean surface. Conversely, if you have warm water expands, displaces water above it, and you'll get a bump on the ocean surface. So here's the chart using satellite data that over a period of about a week covers about every square inch of the ocean surface. So this is Chile, Peru, Ecuador. There's the equator. There's the date line. Central America, Hawaii up here, New Guinea there. You get the drill. Here's that warm, positive anomalies, 5 centimeters, not very high, suggesting modest trades, piling warm water up and warm water at depth, displacing water above it from the date line west of there. East of there, well, it's kind of pretty much neutral until you get to a point, again, south of Hawaii. This is about 155 west Hawaii. Well, there's Hawaii right there. This was much colder and much broader and much more, yelling a stronger signal for cold water at depth. Now it's not. 5 centimeter anomalies from Ecuador out here, one pocket of 10 centimeters, and it's been steadily getting weaker, again suggesting that maybe the flow of warm water is cut off out in this region by warmer water down below, or just the atmosphere isn't really in favor of producing cold water Kelvin waves. Regardless, it just suggests a very weak and laconic La Nina flow. Now you can see some of that here too. Upper ocean heat anomalies. This is the West Pacific here, the East Pacific here. Goes back a year. You can see the flow of warm water from west to east during last year's El Nino finally fading out in November and December, and cold water starting to build. The early signs of La Nina in December and January of 2024. First flow of cold water made it across the Pacific in February, another in March, another in April, another in May, a bit of a break, and then yet another one in July, another one here in September, and we're currently in a break. The question is, will we get another pulse of cold water, or is this the last one, making it 1, 2, 3, 4, 5 pushes of cold water, or 5, I guess you'd say cold water Kelvin waves pushing across the Pacific? We don't know, but we have some models that maybe can give us a hint of some guidance. But before we look at that, let's go look at the ocean surface. I mean, you can have all this stuff going on. You can have your MJOs and your ENSO and your trade wind anomalies, and you can have your subsurface cold water. But at the end of the day, it's what's going on the surface that really matters, because that's what affects the air above it. Okay? On the surface, yes, we do have an El Nino, a La Nina-ish type of pattern. Cooler water off of Chile and Peru, but not particularly cold, and this is all pretty normal. It's really the official El Nino monitoring region. They call it the Nino 3.4 region, from 120 west, 5 degrees north and south of the equator, out to 170 west. You see right here, colder than normal temperatures. not screaming cold, but not screaming warm either, and not particularly strong over here, more like a kind of a Madoki La Nina, if you will, typical of a weak La Nina. Now, where are we? We're in October. I mean, we're 2.5 months from theoretically the peak of La Nina. If it was going to be doing something strong, you would start seeing it by now. I'm not seeing anything that's really screaming crazily that some mad La Nina is building. Here is the sea surface temperature trend for the past 7 days, pockets of, and it's just on the equator that matters, 5 degrees north and south, anywhere from Ecuador out to about the date line. Again, that same sort of mixture of warm and cold, and is not, I mean, this looks almost neutral, if you will, an equal amount and volume of cold and warm anomalies, nothing screaming La Nina building quickly. The sea surface temperature anomaly index in the Nino 1.2 region, the area right there off of Ecuador by the Galapagos. Temperatures today, 1 degree and 312 thousandths of a degree, so 1.3 degrees below normal. This is not an official El Nino monitoring region, but you see the trend. If you draw a trend line through this, it's generally downward, suggestive of La Nina. But this is the official Nino 3.4 measuring area. Temperatures today, we'll expose it there, 975 thousandths of a degree. So 1 degree below normal. Almost seems like it's bottomed out. Temperatures have been on a steady downward climb since El Nino of last winter. Even, I think it was, well, I don't remember when it actually started falling. It was probably right around in here, somewhere in June, something like that, where it went below the 0 mark. Today's temperatures, almost 1 degree. So a weak La Nina would be between 0.5 degree and 1 degree below normal, but it's got to be for 5 consecutive months. We've only been in that range since September, so a month and a half. So weekly moving into La Nina territory. From 1 degree to 1.5 degree would be moderate, 1.5 and above would be strong, and 2 degrees or more would be really strong. So for now, pretty weak looking La Nina in control. One last stop on our tour of signals in the atmosphere giving us a hint at what's going on. The Southern Oscillation Index, difference in pressure between Tahiti and Darwin, Australia. When pressure is lower in Tahiti, since it is in the Pacific Ocean pretty close to the equator, that suggests that we're either in the active phase of the MJO. Again, active phase of the MJO is low pressure moving across the equator from west to east. So it would hit Tahiti, and then you'd typically have high pressure over Darwin. When the index, here's today's index, plus 3.99. When it's positive, that suggests, well, that's not favorable. It suggests some sort of inactive phase of the MJO or potentially La Nina. But 3.99 is nothing. I mean, you'd want to see this up. Well, there was a 15 reading there a couple days ago, but then there was a minus 10. In general, the index has been more positive than negative. You take a 30-day average of that, okay, today's value, plus 1.58. That's basically dead neutral. Where were we a month ago? We were higher a month ago at 9. Now we're at 1.58. But again, the MJO can radically affect the 30-day average, so you take it out to 90 days. 0.80, basically neutral. Neither La Nina nor El Nino. You can go back here, and that's effectively, it hasn't changed at all in a month. That's good news. Let's go look at this on a graph. Here's the 30-day running average of the Southern Oscillation Index. Neutral right down the middle. The downward pushes are the active phase of the MJO. The upward pushes, the inactive phases. During La Nina, the inactive phases are more prevalent and stronger, and you end up here like we were back in 2022 at the end of our 3-year La Nina. When you're in El Nino, the active phases take prevalence, pushing your index down in the negative territory. This was our El Nino, but it was kind of weak. And then ever since then, since February, well, really since December, let's say, we've been just hovering at dead neutral, and there's where we are today. So this suggests that the atmosphere, though the ocean is trying to say La Nina, the atmosphere is going, whatever, it looks pretty neutral to me. That said, we're getting a little bit of mixed signals here because there is this prevalence of easterly anomalies over the dateline in the Pacific. And there is kind of a high pressure bias in the Pacific and a low pressure bias over in the Indian Ocean. But all in all, it's just a mixed bag and not screaming one way towards El Nino or La Nina the other, just maybe a little bit of a nudge more towards La Nina. This is the CFS forecast for sea surface temperature anomalies in the Nino 3.4 range, the official El Nino monitoring range, PDF corrected. You see this and you go, what's going on? My guess is there was actual water temperatures that are supposed to be incorporated in this graph every week or so. The data center in Asheville, North Carolina, where all that stuff is stored. And also the folks of you that are looking for the altimetry data on Stormsurf, that's all coming out of Asheville too. Asheville, of course, cut off from humanity due to the remnants of Hurricane Helene. At some point, they'll get the data center back up. They do at least finally have a landing page up, and I know they're trying to get power in there and trying to do stuff. Other real essential sorts of operations have been, they're rehosted at other NOAA data centers, but this one appears to have some issues as well. But anyway, you get the general idea. Temperatures as we get deeper into October falling to, let's say, 0.85 of a degree, maybe going down to 0.9 of a degree in December. That would be the peak of our La Nina, and only for a couple of months. That's pretty weak La Nina, then returning to normal after that. And these subsurface temperature forecasts, so the Pacific starts here, that's actually about 115 west, and Ecuador is over here. Here is the cold water pool in the East Pacific. Here's the warm water pool currently as is. Well, this is the November forecast, but you get the idea. See the warm water building in December, January, while the cool water slowly fades. As you get into February, the cool pool's gone, warm water in control, filling the East Pacific and taking over by June of next year. It almost looks like, I don't want to say it, I'll just say a ENSO neutral pattern firmly in control. Again, this is going out 9 months or 8 or 9 months. So take it with a grain of salt. But for now, things not looking particularly impressive in regards to La Nina. So for right now, North Pacific swell is on the way to North and Central California. Will sneak into select spots in Southern California, also into Hawaii, though a little bit at an oblique angle. Still decent-sized surf expected everywhere. And if you're not getting that, Southern Hemi swell building at the same time. I think it's supposed to be peaking on Monday into Tuesday. Good-sized Southern Hemi swell. So combo wave spots really will be doing quite well. Relative to California, northwest wind swell really starts pushing in as we get into Thursday and Friday and into the weekend. So probably not great for surfing that time. Get what you can while you can. Looking further out, North Pacific not forecast to do a whole lot for this week, but 2 Southern Hemi storms are forecast. It looks like the beginning of summer again in October. So that's okay. Take surf any way you can get it, right? Beggars can't be choosy, especially during supposed La Nina years. Looking out long. Oh, and a bit of a backdoor trough supposedly pushing down the Sierra, maybe giving a smattering of snowfall up high, but that'll be short-lived and warmer temperatures quickly returning. Looking longer term, yes, supposedly La Nina building, but not very strong. A weak La Nina probably at best. That really hasn't changed now for a month or so. For a minute there, we were thinking that we wouldn't even get a La Nina, but that appears to be fading. We'll have just the weakest of weak flavor of La Nina for this winter. So we'll take that. It's better than a strong La Nina. All right, that's the video for this week. If you enjoyed it, give us that required, pleasantly pleading, required thumbs up. If you have a question or comment, write it up down below. We'd be happy to answer that. If you haven't subscribed, do please subscribe. Hit the Stormsurf icon down in the lower right-hand corner of your screen. And if you'd like to make a contribution to the cause, you can. Hit the special thanks button, the heart with the $ down below, and give us a little tip. We'd appreciate it. And always, many thanks to the folks that are regular contributors and new contributors. I do really appreciate it. That is it for this week. We will do it again next week. Same time, same channel. Thanks for watching.